But anyway, that's the equation. So let's apply this equation to the next question. So a biochemist is thrilled with her discovery of a new enzyme. In order to characterize this new enzyme, she uses osmotic pressure. Yay! Equation written out already for you. A solution containing 0.519 gram of this enzyme in 182 mils of solution has an osmotic pressure at 298 K of 0.83 torr. What is the molar mass of this new enzyme? Okay, so we're looking for the molar mass. But first, let's figure out what do we have and what do we not have, so we can just solve for what we don't know. So 0.83 torr. It actually helps to analyze the situation and figure out exactly what's the path they're going for before you even take it. So we have pressure, we have the temperature. Alright, we know the gas constant. This is a constant, but we don't know the molarity. It doesn't give us here. It doesn't give us the number of moles. It doesn't give us it gives us the mass, but it doesn't give us we don't even know what the compound of enzyme is, so we can't calculate the molar mass. Oh, that's what we're looking for anyway. It gives us the volume, but it doesn't give us the number of moles. Wait. Ding, ding, ding. I just got an idea. It gives us volumes, but not the number of moles. It gives us grams, but not the molar mass. There's a connection there. So let's test this theory out. Alright, so 0.83 torr. Now, here's the mistake I made. It's in torr. Before you plug it in, it needs to be an ATM. And yes, you will deal with an extremely, extremely, extremely small number. Before I do any of that, let's simplify this out, shall we? So we're solving for m, so we get pi. And remember, this is not necessarily 3.14. This is just a symbol, the Greek symbol pi. People might remember that pi can also stand for 3.14, blah, 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 blah. But in osmotic pressure, pi is a variable, not necessarily a number in this case. It's not an irrational number, which will confuse people. Trust me, been there, done that. Alright, equals molarity. So now we can just start plugging and chugging. Well, what is 0.83? First we got to convert this. Now, how many torrs are in ATM? 760, right? So that would mean we would have to divide by 760. Why would you say that? Well, I'll show you. Up here on the side over here. Okay, so we have 700, or no, that's 100. 0.8. And in case you didn't notice, all of our numbers are in 3 sig figs, so we can pretty much safely assume our answer needs to be in 3 sig figs. Alright, so torr, and then there's 760 torr, and we're trying to get rid of this unit, so our unit would be ATM. Otherwise, if we just multiply these together, it ended up being torr squared over ATM. I mean, yes, we're just multiplying by 1, but that's not what we needed. So we need just ATM. So these two would cancel out, so that's why we divide both sides. And that'll end us giving this many ATM, 0.00109. Yeah, not fun. 0.00109. And that's an ATM. Remember, if you need to know what the units are, think of gas laws. Okay? Like the gas constant, 0.0821. And then multiply the temperature, which is 298. Remember, it needs to be in kelvins, like usual. Basically, everything in chemistry is dealt with kelvins. Changes in Kelvin and changes in Celsius is the same. That's why you don't have to convert it to kelvins in. But anyway, so take this divided by 298 divided by 0.0821. So we have 4.46 times 10 to the negative fifth. A really, really, really small number. 4.46 times 10 to the negative fifth. And that's the molarity. That's the concentration. So, now we have the concentration. How do we figure out the number of moles. Well, no. Let's think of it this way. We have the volume here, right? We can assume that this is moles per liter, 1 liter, right? So in solution, 4.46 times 10 to the negative fifth moles per liter in solution. 1 liter. Okay? Well, if now we see here that 0.182 in liters, right? 0.182 liters. Alright, that's the number of liters we have. We're trying to figure out the number of moles at this point. Now realize that these are proportional fractions. These two fractions are exactly equivalent. If you take this number and divide it by this, it will equal this number divided by this. That's all it's saying. Now, how do we figure out proportional fractions? Now this is basic math, really. More like 4th grade math, I don't know. But we do cross multiply this times this equals this times this. This times this is basically x, so basically x is equal to both of these multiplied together. So we take this number and multiply it by 0.182. So we get 8.12 times 10 to the negative 6. So we have 8.12 times 10 to the negative 6 moles. Which makes sense, because a smaller part compared to this will give us a smaller part of the moles, right? So now we have the number of moles. We have the mass of this sample event enzyme. We know the number of moles sample of this enzyme. How do we figure out molar mass? If you don't know, you should slap yourself in the face right now. Molecular weight, or mass, doesn't matter, is equivalent to not moles, grams per mole. That's the molecular weight. So, what do we do here? We have the moles, we have the grams. Basically, we just divide. And reason being is that if we... Basically, this is just a proportional fraction problem, which is why you divide these two together. You would have grams over here and moles over here, and then x grams here over 1 mole, because we're trying to figure out what the mass is for 1 mole. And then so, yeah, if you multiply them out, write it out and it will help out a lot. But we're just going to take the mass here that we have here, 0.519 over 8.12 times 10 to the negative 6. So this is grams and this is mole. So our answer is going to end up being whatever this ends up equaling out to. So times 10 raised to the 6, which equals, well, wow, that's a really big one. And we need 6 sig figs, so 6.39. 6.39 times 10 to the 4th, I believe, right? Yep, to the 4th. Grams per mole. So that's this molecular mass, which is pretty darn big, if I do say so myself. Compared to all the other molecules, water, which is just 18 grams per mole. And realize this is 6.022 times 10 to the 23rd molecules. So to figure out the mass of one molecule, you would just take this and divide it by that number. And just for fun, let's figure out what that is. Divided by 6.022 times 10 raised to the 23rd That's the mass of just one atom. So it's pretty darn small, but still, from what we have worked with before, this is a pretty large answer. This is the correct answer, and it makes sense with biochemistry, but um, yeah, it's pretty crazy.